Cool. So we in a gear there. Pull this up here. Pull the rule up as well. And do this. Okay, cool. And let's put that up. Yeah. Okay, cool. So we in a gear. Uh-huh. Uh-huh. For what? For B? Yeah, B is 62 because angles in the same segment standing on the same arc equal. Right. All right, folks, good evening. So I know some of you all said you're working some of the stuff I would have WhatsApped to you because you have exam tomorrow, whatever the case is. That's all well and good, right? So we're working some circle geometry past paper questions today. All right, we're probably working for the next few days because, as you could see, I have quite a few of them lined up, all the way back from 2024 to 23. Hey, how are you doing, Josiah? Okay, cool. Right. So this is the 2024 May paper. So the most recent CSEC exam. This is the question from it. Right. So let's take a read. Right. So it's a little small. Right. So hope that's hey, what's going on? Leave yourself. All right. Hold on. Just now. Sorry. I'm going to have to detach it. This was happening yesterday in our maths, and I had to. Hey, Bunny, you know how you doing? All right. So. Put it this way and put it this way so that the connections stay the same. Hey guys, sorry. It just blinked out. It's gonna blink back in. Let's give it a couple of seconds. Right. So I see us back up and running on Google Meet. I see us back up on TikTok, Instagram. We're back up on. Right. Okay. Cool. All right. So let's take a read here. So it says that V, X, Y, and Z lie on the circumference of the circle shown below. Whoops, why did that happen? I don't know. So V, X, Y, and Z lie on the circumference of the circle shown below. Okay, cool. Next, what did they say? Center O with diameter VY. Diameter VY. Let's put that in a nice orange. Right? So VY is here. That's a diameter. Right? A diameter cuts a circle in half. Half a circle is called a semicircle, and the angle in a semicircle, and the angle in a semicircle is the angle in a semicircle is 90 degrees, right? So where would that angle be here, by the way? We'd have to build a triangle using that diameter such that all the vertices touch the circumference. So it means that this whole angle here is 90 degrees. Let me let in gyre. 1 second. Oh, let me finish taking my rule too. Sorry, I was taking my rule and I got distracted by something. Right, so that. Evening, Jai. How are you doing? Right, let me put that you are here. Right, evening. Good job. So Aisha here, D'Angelo here. Right, Juliana out until December. Sorry, not Donovan. Juliana. Right, where is he? Right. Janaya was here. Right, Josiah is here. Jaquan not. Didn't see Logan. Matthias out. Mikhail's supposed to. No, Mikhail is here. Sorry, my bad. Paige is unfortunately unwell. So that's why. Oh, hello, wife. How are you? Good to see you on. Yes. All right, cool. Right, so back at it here. Right, so we here. So we have that angle in a semicircle is 90 degrees. Right, now, what else is telling us here? UW is a tangent to the circle at V. So UW is that line on the outside. Let's put that line in, what color we like him, boy? Oh, okay. All right, guys, just give me 1 second. Let me just print out something for Zian there, jump in the dance. All right. All right, sorry, just give me a minute. I'm just going to finish print real quick. Yeah, I was actually on the wrong page. It's the same question, but I was on the wrong page. let's get back there, shall we? Right. So sorry. Let me just put in my colors again there. Sorry about that. Right. So we were told that Vy is a diameter. We talked about that just now. Let's go to a slightly brighter green. Right. Right. Well, that must sound like bug spray. All right. So UW is a tangent. Right. So we learn about some. What's going on with this thing? Hey, behave yourself. Philip, behave yourself. Let's try that again. Sorry about that. What is your right? Cool. Left it. That's good. Sandra Austin. Good evening. How are you doing? Right. So we have a tangent to the circle, and we have a what you call it? A diameter. Now, half of a diameter is called a what? A radius. So the radius starts at the center and goes to the circumference. So OY is a radius, and OV is also a radius. And we know about a couple of rules with tangents and a couple of other lines, right? What's the rule about the angle between a tangent and a radius, guys? 90 degrees. So where would that 90 degrees be? It would be on this side here and on this side here. So you have two 90-degree angles. All right. Now, we also recently learned about the angle between a tangent and a chord. All right. So we have a couple of chords here, right? Oops, sorry, my bad. We have a chord here, the blue line, right? And what do we learn about the angle between tangent and chord? That angle A. Right, the angle in the alternate segment, that's correct. So what angle would A be equal to here? 62 degrees, right? For that exact reason we just cited there. And let's put this other chord in a, sorry, let me get a slightly heavier weight on that point. Counting today, they're just the two next week, and then we start trigs from scratch in early December. Right, we'll get 8 sessions in December. That'll more than cover the first half of trigs. Right, January exam prep. I have to send a poll or something in the chat, and you will let me know. And I'll try and schedule some days and times to do that. We'll just try and go through whole papers, or you all can let me know specifically what topics you all want to do. Right. So this angle across here, let me get a slightly lighter weight on that. So this actually, yeah. So this angle here, right, will be equal to what angle? Well, it actually be equal to the sum of D and E. Right? Yeah. No. The last time they changed the structure, it was 2019. They just made all 10 questions compulsory. The last time, before that they changed it was, I think, 2010. No, they don't change the structure very often. I know. I'll have to ask around, but I haven't heard anything about any changes to structure. They added content to the probability section. Yeah. So some of this stuff from AdMaths they push down there. I don't know why. It's not. Trust me, it's not like AdMath worthy. It's very, very simple. Right. Anyhow, so folks, we had to find angles. So hold on. We have two sets of it. It says state a theorem that justifies the values of each of the following angles. Right? So for angle B to be equal to 62, let's see. So where's angle B? Angle B is up here. Equal to 62. So what rule we said that was? I think Jade knew to me earlier, right? Sorry, Javier. Angles in the same segment standing on the same arc are equal to each other, right? Yeah. So the kind of butterfly or bow tie rule. The angle's up in the corner, right? So again, they're asking for the reasons here. So give them the reasons, right? So the reason here is that angles in the same segment one sec. Standing on the same arc are equal. Okay, so that's angle B. What about this angle C is equal to 124? Where's angle C? That's in the center there. So why would angle C be equal to 124 degrees, boy? That's correct, right? If we let's take, I guess I could take off some of the colors. Actually, hold on. Let me go across here. Let me use this diagram because I kind of did my right. So if we, okay, no, let me choose a slightly narrower thickness, right? Right, yeah. So the angle at the center is double the angle at the circumference. I could agree with that. Very good. Good spot. I almost didn't spot it there for a second, eh? So yeah. Right, so this one is the angle at the center. Uh-huh. It's double the angle at the circumference. Okay. And angle OVW is 90 degrees. So where's OVW? Yeah, that's correct. Let's check out OVW. Right? So yeah, O to V is a radius, that's correct. And then V to W is piece of the whole tangent, right? And the angle between tangent and radius is 90 degrees, right? Right. Okay. Are we okay with those three? Any questions? Anybody? Anything? No? All right. Google Meet. So Aisha, D'Angelo, Jerry, Michael, if you guys are good with those three, just kind of give me a quick G in the chat. If you need me to re-explain any of them, just let me know. I see an F. I think F next to G, so. All right. And Michael will let me know when you're ready. Right. Did I mark on everyone? Ask Michael. Right. Logan not here, Jacon not here. Right. Okay. Right. So your question? Oh, okay. That's okay. Right. So same diagram but different. So we had to find angles A, D, and E now. So let's zoom in here. So they want to find A, D, and E. All right. So angle A. All right. So angle A is here, the pink one. Angle D is here. And angle E is here. Right, so we have a pink, a blue, and a green. Right, but we already solved for angle A earlier, didn't we? Yeah. Angle A is 62. Now it says show all working where appropriate. And this is 3 marks, so it's 1 mark each, right? Angle A, well, angle A is between, sorry, one sec, a tangent and a chord. All right. All right, but what's the rule there? The angle between tangent and chord is equal to the angle in the alternate segment. Right, so on the kind of opposite side of the triangle there, which would be, which angle? 62. So I think not, because in the previous question they specifically asked for the reason. To be safe, I would say still write it. Once you have time, let's say, for example, you were in a crunch situation, you had 2 minutes for this whole question, just put the angles, right? Right, but for the sake of illustration, so like when I send the solutions, etc., I'll write it in, right? So angle between tangent and chord equal to angle in alternate segments. Right? And they give you real room, so, right? Now, angle D. Any thoughts on angle D? Uh-huh. Yeah, let me give Khalifa a chance. No? You sure? Okay, go ahead. Right if is a diameter. Right, so you're saying from here, O to V is a radius. That's correct. The whole angle here would be 90 degrees. Uh-huh. Okay, right. So this angle out here is 62. That's what we just found. So they say 90 minus 62 will give us the angle on the inside. Right? No, you're correct, and let me tell you why. Because don't forget, so you started off good, and you went off on a, well, no pun intended, a tangent, right? No, you're not wrong. You're correct. But what I was hoping you would spot is also this line is also a what? And if you close up your triangle, what kind of triangle you have? Because two radii make up two sides, right? Which means that these, hold on, let me go back to my green. That these two angles here and here are equal. So this is also angle D down here, right? So if we already know angle C from the previous part of the question, which told us it was 124, right? So all we have to do therefore is 124 from 180 and then divide by 2. So why? Because, right, because so 1, yes, we subtracting from 180 because the sum of the angles in a triangle is 180. And then we divide them by 2 because, as you said, the base angles of an isosceles triangle are equal. Right? Now, again, you see something Javier just asked, do we need to write the reasons if it's just for 1 mark? So I've asked my friend Kirk this, and my friend said, tell them to write the reason. Sure, no problem. Right.
I thought you could just do 62 subtract 9.
Yeah? Yeah, if you do subtract 90, you will get this value here, which is equal to this value here, because they are base angles of an isosceles triangle. Yeah, I was saying you could consider the whole triangle, right? Because we know that the angle in the middle there is, sorry, let me get a different color. This angle is 124, because we saw from the previous part of the question, they told us that, and it was because the angle at center is double the angle at circumference, right? So we could subtract that C from 180 and then divide by 2. But the other way that you guys started with is equally as valid, eh? The whole angle here is 90. We have a 62 degree portion outside. 62 from 90 will give us 28 degrees. And this across here is also 28 degrees. Yeah. 124 from 180 is 56. 56 divided by 2 is also 28. All right. So for angle D, all right, so we have 2 sets of work in here. So I'm going to put one in a, actually, hold on. Yeah, okay, so it's green. All right, cool. Uh-huh. It's 1. It's 1. Yeah. Well, yeah, 1 of each type usually, yeah. Well, 1 of whatever they bring. All right. Right. So D. So one option is you could say 90 degrees minus 62 is equal to 28 degrees. Now that's angle OVZ, right? OVZ. That's the angle down to the bottom there. We wanted this. So you had to state that those two are equal because it's an isosceles triangle. Right? So this is angle OVZ, which is equal to angle D. Right? Because it's base angles of an isosceles triangle. Ah, you go. Hey Trinity. Hey, how you doing? Long time no see. Shiva, how you going, Shiva? All right. Base angles of an isosceles triangle are equal, right? And we know it's an isosceles triangle because OV and OZ are radii. Those two lines from the center of the circumference, right? So OV is equal to OZ radii, right? And then the other way that we did it, right? The second way was we did 180 minus, what was it, 124, and then divided that by 2. Right, so we had one item here, 2, and then 3. Right, so reason 1 was interior angles in a triangle sum to 180. All right, 2 now. Oh, here's Janai. Let me let in Janai. Hey Janai, evening, how you doing? Good to have you on. Right, we're still working the first question, which was May 2024. We're just taking our time to do it. Right, trying not to rush through. Right, second thing was C question 1. Sorry, C part 1. C part 1, part B, right? So C part 1, part B. Sorry, just 1 sec. I guess it's a message from my wife. How you doing? Okay, sorry. C part, and then 3. Base angles of an isosceles triangle. Base angles of an isosceles triangle. Right, and angle E. Right, so let's go back and take a look at angle E. All right, so what are we thinking for angle E, guys and girls? Yeah. Uh huh. Mm-hmm. Mm-hmm. Yeah, yeah. Add up to 180, that's correct. Mm-hmm. Ooh, what went on there? Yeah, go ahead, I'm listening. Right. Yeah, I agree. So if we consider this triangle here, yes, the sum of the interior angles will be equal to 180. So we have 62 at the top. To the bottom, we have 28 and 18. And then we have another 28-degree piece on top there. So the only portion missing is the E. So we could add up all of the other angles in the triangle and then subtract from 180. Yeah. Other than that, I'm not sure how to find that angle, to be honest. Right, so 62, 18, 28, and 28. Right, cool. Yeah, man, what's going on? That was blue? Okay, cool. Right, so 180 minus 62 plus, what was? 18, 28, and 28. Yeah, how did 62 first? Right, so 62 and 18 is already 80. 28 and 20 is 56. 80 and 56 is 136. 136, right? And therefore that's equal to 44 degrees. Tiffy as in Tiffany. Moving on. Philip in the house. Right. Okay. In class, people, are we okay with E? Blue? Any questions? Anybody? Anything? Cool. All right, Google Meet. You know the drill. If you guys good with that, give me a G in the chat. All right, I have about 5 of you all there. Where's mine? Oh, there you go. It was on the screen. Oh, thanks for sharing, Tiff. Appreciate it. Okay. I don't think I got all my G's, but all right. All right, cool. Sorry. Yeah. Yeah, guys, check this. This decent way, this real cool way. Khalifa thought of, right? Right. Yeah, guys, check this way, right? So a lot of times when we have radii in the circle, we forget to use them. Right? So check this. The center is O, not so? Any straight line from center to circumference is a radius, and all radii are equal in length. Which means if we create a triangle here, it'll be an isosceles triangle, not so? Okay. Now we know that this is 62 and this is 62, not so? Right. And we know that this whole angle here will also be 62 because base angles of an isosceles triangle are equal. And on top of that, if you follow your bow tie, right, this angle here would be equal to this piece here. Which means to find angle E is 62 minus 18. And 62 minus 18 is 44. Right, so this piece here, so the whole thing is 62, and the yellow piece is 18. And to find the non-yellow piece, which is angle D, is 62 minus 18, which is 44. So good job. Sorry, did somebody in Google Meet say something? I swear I heard something. I swear I heard something, but I'm not seeing any. All right, okay. So that's 2024 May. So it was a slightly above average question, to be honest. But as you can see, if you take your time when you go through it and you inspect and you look and you apply your rules, it was doable, right? But of course, you have to watch your time as well. Okay. Okay, so I'm gonna print out the Jan 2024. So those in Google Meet, you'll have the PDF already. It's in the WhatsApp chat. You can download it, open it in a browser as in a separate window, and take a look, right? 1, 2, 3, 4, 5, 6, 7, 8. Oh, 9 people. Okay, cool. So give me a second. Right, so you can take a look at it in the meantime. Right? What is O usually? Center. And any straight line coming from center to circumference, like OK and OL, are radii. Right? So just as we just saw, being able to spot the radii could help us to identify solutions to questions more easily than not spotting them. me just print this for the class and then we'll go from there, right? Yo. Would be what? Neither. Because for that to work, you have to have a triangle where all three vertices touch the circumference. And if you look on the inside, that's actually a quadrilateral. All right, you all finished? All right, cool. So next week, or you'll have a next session on the weekend? Okay, cool. All right, well, we here? All right, later. Bye. Oh. Hey, Daryl, how's it going? Hey, Ethan. Hold on. I was the message you just now, because you had responded to a story last night. This one, you'll notice that they ask you for angles based on big letters, three big letters. So you have to be able to identify angles by big letters. Okay, guys, let's take a look. All right, so of course, we'll take a little preliminary read of the question. So K, L, M, and N are points on the circumference of a circle center O. All right, so we have K, L, M, and N. Now, just by the way, what I like to do sometimes is I like to kind of blank out certain lines to make it easier to see things. So, for example, if I were to blank out that line, oh, who's this from? Oh, that's from November, December. Yeah, I guess so, yeah. All right, no problems. Thank you. All right, so if we blank out, let's blank out this line here too. Right, so if I blank out those lines, and let me blank out the angle here as well. Are you all seeing the cyclic quadrilateral? All right, cool. So the rule with cyclic quadrilaterals is that the opposite angles are supplementary. They add up to 180. All right, now I'm not seeing any scope for that right now, but I didn't really inspect the whole question just yet. But let's see what they're asking us for initially, right? So xy is a tangent. So xy is this line on the outside here. And we know we have some rules of tangents, right? The angle between a tangent and a radius is what? 90 degrees, right? And if it's a chord, it's equal to the angle in the alternate segment, right? So that's one there. Now this chord is a bit of a red herring because we have a 48-degree angle here, but the rule with the angle and the chord has to do, as we saw, has to do with a triangle, not so? If we block out the radii, yet again, sorry, and not just the radii, let's block out these lines here, right? Sorry, I'm gonna get a brighter color, right? What we will see is this triangle here. And inside of there, what angle would be 56? The angle by what letter? Right, so 56 exists here, right? And that's the angle between tangent and chord. So on the inside of the triangle, the angle by M will be 56 as well. That's correct. Okay, cool. Right, so you see, as you're going through the question, you could pick out certain things, right? But again, you all don't have the luxury of blanking out lines and putting them back in. Right, so that's something I'm just trying to show you here so you could maybe hopefully try to recreate that with your own brain. Right, now what else they're giving us here? LKY is 48. So LKY is 48 degrees. MKO is 12. And XKN is 56. Okay, cool, no problem. So find the value of angle KOL, giving reasons for each step of your work. So KOL is the angle at the center of the circle right here. That's interesting. Okay, cool. Right, so in case anybody needs a little hint, I'll just remind you of something we said a bit earlier, right? That OK and OL are radii, and what do we call, hold on, what do we call XKY again? As a tangent, right? So there might be a rule or two be governing tangents and radii. Yeah? There's a 90-degree angle somewhere in the middle there. So this line and this line. Right. So here's my question. So between which two lines will we have the 90-degree angle? It's on both sides, that's correct. Right? But if we're looking for O, right, let's talk about here. All right, cool. So that means that we have a 48-degree portion, and we could therefore, if we had to, find the other portion on the inside, which would therefore be equal to this portion here. Sorry, I kind of spoiled it for somebody else. My apologies. Sorry, I am Patrice. Patrice is still there? Yes, okay. And they love Didi. Right, so Patrice, 96. 48 and 48 is 96. So that's the sum of those two purple angles. And if you think about it, what's the sum of the angles inside a triangle? That's 180, right? So you might be able to use that and the 96 to find that pink angle in the middle there. Right? 96. So good try, Patrice, no problem. Right? Again, give me suggestions, even if they're wrong. That's not a problem. It shows you're still willing to try. All right? And we could use sometimes, we could use those things to help us find the right thing. Right, so 96 is 48 and 96. Oh, it's 42. Sorry, it's 42. It's 40, not 96. It's 42, which means 84. And then 84 from A is 96. Oh, yeah, 96 is correct. Oh, yeah, it is 96. What, Patrice? Sorry about that. My apologies. I worked it wrong. I was the wrong one there. Patrice was correct. Good job, Patrice. Huggable Creations. Wait, that is Joshua, that is you? Yeah. Yeah, thank you for understanding. I am a little tired. Right, so the red angle here is 90. Angle between tangent, orange, and tangent, green, and radius, orange, right? So that red angle is 90. And it's made up of the blue and the purple, right? 48 and the purple. So to find the purple one, you have to subtract 48 from 90, and you get 42. Now because, the triangle is isosceles because OK and OL are both radii, which means they're equal in length, not so? So we have an isosceles triangle. So it means that the angle on the left, the purple, and the angle on the right are equal because it's an isosceles. So when you add up those two, and you're looking for the third one, we could just subtract those two from the 180. All right, hold on. Let me start over. Right. 48. No. You don't have a minus 12. 12 have no part to play in it. Yeah. You see how when you have excess information, it clutters the visual space and makes you think certain things are relevant when they're not. Right. Okay. All right, cool. So let me talk. Right. So KOL. So first of all, we could take it in a kind of order. So KOL would be equal to 180 minus 42 plus 42. Yeah? Right. Correct, yeah. 48 from 90, yeah, that's correct. Erisa, evening, good to see you again. Right. 180, so that's 84, and that'll give us 96 degrees, right? Now the 42, right? That was 90 minus the 48. And that's equal to 42 degrees, right? Sorry, right. Okay, hold on. So we gotta get some reasons, right? So our reason here, the reason for the 90-degree angle is because angle between tangent and radius. Right, is 90 degrees. Well, sorry, I should do this. Sorry, Sharpie. Hey, what going on? KNM. KNM is 48. What's your rule? Cite your rule for me. If you don't give me a rule, I tell you if it's right or not. And actually, we could find KNM, you know. Right, sorry. And then for the 180, right, so we have two rules governing this one here. Right, interior angles of a triangle sum to 180. Angle between chord and tangent. Right, that rule is the rule you would normally use for something looking like that. Interior angles of a triangles sum to 180 degrees. Yeah, just now, Christian. I'll get to you. Because somebody else in class said the same thing. However, there is one little thing. And then right, and the 42 by 2 is because God, my line's gonna get across here. Crap. And then also base angles of an isosceles triangle. Oh, sorry, I'll put that OK equal to OL is equal to OL, which therefore implies that triangle OKL is isosceles. He's asleep at 7:20. He's not well. Right? Which therefore implies that angle OKL is equal to OLK. That's the 42 degrees, right? Right. Okay. He spit out half of the corner. Oh, Lord have mercy. Sorry, guys. I've just sent him a message. Right, okay. Let me try to reintroduce some lines. Right, so we have alright, so are we okay with KOL? Any questions, anybody, anything? Alright, Google Meet, if you guys are good with that, give me a Genie chat. If you need me to re-explain, that's not a problem, let me know, and I will do such. Okay, cool. Alright, cool. Thanks, Mikel. Sorry, I didn't put that Zian is present. He is present. Most present. That's Aisha, Janaya, D'Angelo. Right. Yo. Let me put it this way. That box has 10 reams of paper. Each ream has 500 pages. That's 5,000 sheets, right? If it's not exam season, that could last 3 months. So basically a term not counting exams, right? Exam season, which is just me, I might go through a box. 5,000 pages. And mock, about the same. So you see around April, May, real paper and real toner. No, that's just exam season. If it's not like if it's regular, like September, October, November, I buy that box must see September, maybe October, and then it's not even half done yet. That'll last the rest of the year. And that box is about 300 and change. Not bad. Yeah. Ricardo Young boy, we're going on Ricardo. Okay, cool. Sorry. Right, so that's just part one of the question, guys. Sorry, so somebody was asking, somebody online, actually one of my former students who went on to teach more than me because he went on and do A-level maths and thing. And he's a certified financial planner now. So if all they want to start planning your future, you could let him know, right? He was asking if this angle up here is also 48 And he was citing that the reason he's using his rationale is that the angle between tangent and chord, right? Right, but that only applies. What we could do, we could even. I not realize I was writing on new master copies here. Okay, that's serious. It's alright. I was supposed to copy and paste them inside the 2024 file. I'll do that after and then just clean it up. Right. So Christian, for that rule to apply, Christian, if you're still there. Oh no. Okay, you go on. Sorry. Yeah. It has to be a triangle, right? If it's not a triangle and it's a quadrilateral, it doesn't seem to apply. I don't know if there's a rule that does apply, but we might play with it. Anyhow, yeah. So hold on. Okay, let's go to the second part of the question. So it's the same diagram. They want us to find LMN. So let's identify where these things are. LMN. So LMN is this whole angle here. Let's call it X. Or the opposite angles of a cyclic chord. Yeah, I'm not sure how else you'll find it, to be honest. We could do a piece by piece. Actually, we could break it up into two pieces. But let's see if it's necessary. The next angle is KLO. KLO. Now, we just found that, didn't we? Let's call it Y. Yeah, that one is 42 degrees. Yeah. That's weird. Oh, angle X. And then MLK. So we'll call that one angle Z, right? Oops, sorry. Let me just change the weight on that tip. All right. Karima vibes. Oh, sorry. What was MLK? Yeah. MLK? That's this angle here. MLK. That's the whole triangle. What about it? For it to be isosceles, two of the angles have to be equal. Two of the lengths. I don't see that that's the case here, but the diagram isn't drawn to scale, so I can't guarantee whether it is or not. So the bigger one, as in this one here, right? So we don't know if it's isosceles. I mean, we could try to prove that. That would help us. But if we do that, we could say that maybe these two angles are equal, or maybe these two. Right? It would be nice, but we'd have to find a way to prove it. All right. Okay. So hold on. Let me starting from a different place here. Right. So we have those three angles. So actually, yeah, let me. Oh, sorry. Oh yeah. Let me have a think here because I'm not Hold on. Yeah. As in this whole thing here? So like what, this one here and this one here? From one. Okay, if you could have find those two angles on either side of the 12, which we can. We do, because we already know that this whole thing is 42. So we know this is 30. Right? And this one across here would actually be 34. Because this is a radius, there's a tangent, and the angle between tangent and radius is 90 degrees. So if we have a 56-degree portion on the outside, we could find the portion on the inside. Right, so let me put in my little right angle thingy there. Right, so we could find all that. So we could add up those three angles and then subtract it from one to find x. We could do that. Okay, cool. And then, well, we already know angle Y. All right. And to find angle Z, angle X is 56. As any pink angle? Why is it 56? 10, 12 is 42, 42. That's 70, 76. That's 104. Which interestingly is some of these two angles here. All right. Oh, sorry. Brent Wong? As in from Trinidad, who was living in Canada now? Yeah, question? Oh, okay. Sorry. Ah. You have Enderton PUA tomorrow. Who's that? Rex Gibson? Or Real Gibson? Well, good luck tomorrow. Let me know how it goes now. Nonchalant. All right, LMN. Yeah, to find X, we could use that the opposite angles of a cyclic quad are supplementary, right? We could subtract this whole angle from 180, and then we will get 104. Right. Now we already found angle Y from the previous part of the question, so it's 42 degrees. We know that already. To find angle Z, right? Yeah. I hear quadratic, I hear all kind of thing. The cyclic quadrilateral? Right, so what's the question you're asking about it, sorry? The rule is that the opposite angles are supplementary. If we were to produce a side, the exterior angle would be equal to the opposite interior. But check this, right? We're forgetting one of our primary rules. What rule is that? Angle at the center is double the angle at the circumference. Now we already know this angle. Didn't we find KOL in the first part of the question? What was it? It was 96. And then that would correspond to this piece here. Sorry. That would correspond, so this angle here is double this angle here. And we were able to find angle X from the first part of the question. So we could subtract, well, yeah, and we wouldn't need that piece, right? So check it. If we already know angle Y, right? So we could actually, and subtract from 180. So it's like what we did in the previous part of the question. Sorry, the previous question, right? If you focus specifically on this triangle here, what's the sum of the interior angles of a triangle? 180. We know this piece is 30. We know this piece is, how much it is again? 48. And then we know this is 42. So we can add up 42 and 40 is 90, 90 and 30 is 120. So this piece here will be 60. So you had to add 60 and the 42 to get 102. Yee. Huh? Right, because, one second. It's open. Right. Yeah, so guys, we found KOL in the first part of the question. That was 96 here, right? But here what we're going to do. Right, the diagram getting messy. So what I'm going to do, I'm actually going to copy and paste the diagram so we could actually find for each one separately. So we don't clutter up the diagram, right? Because if we have to go back and revise this and review it, what's the point of doing that if everything cluttered and difficult to understand? All right. Okay, so let's deal with one thing at a time. So in this diagram, in this particular version here, we're going to focus specifically on LMN, right? LMN is this whole angle here. Right, so again, you could just call it angle X if you want for now, right? That's just something I'm doing. Right, now, we identified a couple of important things here. That this line here is a radius, and this line on the outside here is a tangent. And the angle between tangent and radius is, so we have a 90 on this side, and we have a 90 on this side, not so? Yes? All right, good. Now, what we could do is we could find this angle here by doing 90 minus 56, right? And we already technically have the piece on the inside, look at it from here, right? This whole angle here is 42 because we found it in the previous part when we were finding KOL, right? So let me just blank out the 12, right? So, sorry. This whole angle is 42, right? So that angle is 42, and then 56 from 90 will give us 34. So if we add that blue and that purple, we get the total value of that angle in the corner by that side, right? Okay. So, again, if we, what color could you use here, boy? What color didn't use? Okay, I'm going to use the pink, right? Right? What we may not have done is we may not have remembered that this is a what? Cyclic. Oh, good. Right. A cyclic chord, right? Hold on. Right. And the opposite angles of a cyclic chord are supplementary, not so? So that means they add up to? Sorry, let me just answer this parent real quick. Hey, Andrew, vibes. We can do that. Right, so to find the value of angle X, right, that's equal to 180 minus 34 plus 42. 34 and 42 is 76. 76 from 180 is 104 degrees, right? And what I'll do here is I'll put a couple of little work in. So this one, the 42, that was 90 minus 48. And the 34 was 90 minus 56. And for both of these, that was angle between tangent and radius. Right? And this one, this rule here, is that opposite angles of a cyclic quadrilateral are supplementary. So opposite angles of a cyclic quad add up to 180 degrees. Yeah, that funny looking E is a sigma symbol. It means add up to, or the sum of, right? So opposite angles of a cyclic quad sum to 180, right? So that's the first piece. Okay, Google Meet, just give me a quick GFIG with this item here, please and thanks. Right, if you need me to re-explain, it's not a problem, but you gotta let me know. Okay, all right. In class, people, we okay with angle X? Right, Curly Fuzzy Arm, we okay with that one there? All right, Jaden, Noah. Right, my corner crew, all you okay with that one? Yes. The match done? What was the result, boy? The match done? It's still good? Oh, right. Okay, so I see an Aisha, Mikhail, D'Angelo. All right, thanks. Still? Then stop it out. 87 still? What? Oh, okay. All right, cool, well. All right, so that's that first part, right? So like I said, I can find in one question to a page so we don't overclutter, right? Now they want angle KLO, which is angle Y, all right? Well, I'm calling it Y. So KLO is this angle here. Now we already found that angle in part one to the question because it was an isosceles triangle and we were able to find this one here by doing 90 minus 48 because angle between tangent and radius is 90 degrees. We had a 48-degree angle, so we found 42. Right, cool. So we don't have to over-explain this one. Let's just put 42 degrees, C part 1, C part 1. Okay, cool. Right, so that one was a non-starter. And the last one was MLK, right? Okay, so let me zoom in here. And we want MLK. So MLK is this angle here. So that whole angle they want. They want this whole angle here. All right, so we let's fill in some of the other angles that we have, right? So hold on, sorry, I have to zoom out a little bit. Right, so we know that this angle here is 34 degrees. This angle here is 30 because the whole thing is 42. And if this piece is 12, we need 30 more to make up the whole 42. All right. We also know this angle here. Everything all right? Okay. Right, so 42 and 42 is 84, 84. So we found 96 from the first part of the question, right? And that gave us that this angle here was 48 degrees. Right? And we know from, again, the previous part of the question that this angle here is 42, right? Now, that means that all we have to do actually is add up 48 and 30 and subtract it from 180. Because the sum of the angles in a triangle is 180 degrees. Right? So let me actually get a little. Right? So I thought I would have turned to a straight line, but I guess I was wrong. All right, I'll draw that one over. Right, cool. I know where I get R, but I'm gonna worry with it. Okay, cool. So, right. So all we have to do, so we don't even need the 42 degrees. We just need 30 and 48 added together and subtracted from 180. Cool. So let's do that and call it George. Oh, we have a fourth one. All right. Sorry. What was the two angles we had? Sorry. 30 and 48. 30 and 48 is 78. 78 from 180 is 102. And the last one is KNM. Well, let me see if I can fit KNM here. Oh, look where KNM is. KNM is here. Oh, no. Come back to me, right. So like Ian Ali. Come back to me, right. Go away. Right. Okay, and look at that. The blue angle and the orange angle are opposite angles of a supplementary. Right, sorry. Elena. Yes, I am on YouTube as well. The YouTube stream is actually private right now. But you can find me here and on Instagram. Tonight. Just tonight. Let's testing out some stuff. Sorry. Well, today was Max the scheme. Most likely. Okay, glad to hear that. Huh? 102. Because 30 plus 48 is 78, right? And then 78 from 180 is 102. So block out that line. You see the purple triangle? Yeah, right, cool. Anybody here has played Blocks Fruit? Yeah. Or it have an Yeah. Then my next game attached it like where you said a rule stuff, you said to put something to rule, like you get aura or something. Anybody know about that game? Now I only ask because my stepson has played this game, right? And he and his pal on a morning going to school in the back of the car talking about it like crazy man, right? He asked me, I heard him talking about something lobotomy. I'm like, what is that? Is that aura? Like what? I say, hold on, spell that for me. Lobotomy. I say mean lobotomy. You're like, nobody say it like that. I'm like, nobody with a correct brain, anyhow. But the one yesterday, I heard him saying Southern. You see, Uncle Chris, how you spell Southern? I like Northern and Southern? You're like, no, like SOVREIN. I say, you mean sovereign? Him. Nobody say it like that. I drive it and I want to talk the road. I'm like, the word is sovereign. It means like a king or a king. Nobody say it like that. I'm like, oh my god. I say, well, hold on. I say something in the game. You say, yeah. I say, okay, here what? Let me come and see the game and see what it is. Right? Because like it's like you counting and you can't even talk for it. 1, 2, 3, 4, 5, 6, 7, 8. Like, anyhow. Anyhow, right. So to find angle at n, the orange angle is 180 minus the blue. Right? And that's 78, right? This is because opposite angles of a cyclic quadrilateral are supplementary. Sorry about the scrappy writing, by the way. All right, Google Meet. Just give me a quick G if you guys go with those two, please, and thanks. If you need me to reaction either or, let me know. All right. Khalifa, you okay with them? That was on ish. You sure? All right, Zian, talk to me. You good there? All right, cool. Javi? All right. Noah and Jadon, you good? All right, cool. Naila, Shamo, you good there? Josiah, Jaziri. You sure? All right, okay, cool. All right, I get 3 out of 5 people. 6. Okay, 4 out of 5. Nice. Okay, cool. So on to 2023. And I had to print this off with the purple in them in clears. So let me just do that quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mm-hmm.
If the number of elements in A is equal to M, then the number of subsets of A can be expressed as
2 to the power M.
right?
Yeah.
Okay, and this one. A intersect B prime. A intersect B is here.
No. A intersect B prime. So that's actually just what we call A only, right? B complement is everything outside of B.
Right.
And where A and that overlap is just where is A only.
Because A intersect B would be in the middle here.
A intersect B will be there, but this is A intersect B prime.
Which is so
B complement, yeah.
dotted B.
Correct.
So A only.
Correct. A only, yeah. Okay, we're going to zoom in here. Right, so this is May 2023. Right, so let's take a read. Right, so L, M, N, and R are points on the circumference of a circle with center O. L, M, N, and R are points on the circumference of a circle that has as its center O. Before we read any further, if O is the center, what does that make those two lines? Correct. So ON and OR are both radii. which means that if we close up the triangle ONR, what kind of triangle is that? Right, isosceles. And we have the angle inside, right? 156. So we could find these two angles down here. How? Subtract 156 from 180 and then divide by 2, because the angles in a triangle add up to 180 and the base angles of an isosceles triangle are equal. So that's very quickly. 156 from 180 is 24, and 24 divided by 2 is 12. That's correct. Very good. Okay. Right. Now, we have the next. So PQ is a tangent. Let me put PQ in a green. Well, I can see that green? Yeah, cool. Okay. Ravino vibes. All right. So we have some rules about tangents and certain lines. Right? If we talk about the so let's take back this, take it back, right? So hold on, I'm gonna put it in a different color. That's a blue, right? Well, you see the blue? You know what? Hold on. Let me just put it in a slightly thicker line so it's just easier to see. That's blue, and I'm gonna put this one in an orange. Right. Okay. Cool. Right. So the blue line and the orange line are both what is called those lines in a circle? Those are chords. And it, hold on, that one a little too thick. Too thick. Right. So the blue line and the orange and the purple as well, right? But the blue line and the orange line, they each have an angle with the green tangent, not so? Okay, and what's the rule with that? The angle between tangent and chord is equal to angle in the alternate segment, right? Okay. So let me outer colors already, boy. Things bad in the camp. Alright, small thing. I will just use green. Right. So this angle here, this green angle here, E, what angle on the inside of that triangle would it be equal to? The big triangle. Angle R. That's correct. So E and R would be equal because angle between tangent and chord is equal to the angle in the alternate segment. And if we count this as the orange angle here, inside, this would be the angle corresponding to that. That's 48, right? Okay, so you see how we kind of fill in blanks as we go along? Right? So when you get these questions, try and figure out whatever you could figure out, right? Okay, now check it. We could find E quite easily because think about it, right? This pink line here is a what? A radius, and the angle between radius and tangent is 90. So if this piece is 12, can we find E? By doing what? 90 minus 12, very good. So that will give us E, then we could find R from that, and the last thing we have to find is A. Now, check this, give me 1 second, Right. I'm gonna erase some colors here, because I want to blank out some colors now. Right. That is correct. So let me take out. Right, so say it again for me, Khalifa. Angle A and this angle across here would be, because they are opposite angles of a cyclic quadrilateral. Very good. Right, so you see sometimes it's like pulling at a thread. You pull at a thread and the whole thing eventually might just unravel. All right, so keep at it. Right, and we could find that pink angle across there, right? Because we already know that from our previous part of the question that this, no, sorry, I took the wrong thing, right? That this piece here is 12, right? And we know that since this line is a radius, and this is 48 here, you could subtract 48 from 90 and get 42. Yeah, so you could add up those two and get 54, and that angle again. Sorry, I've given away the question, my bad. All right, okay, so going back here, so let's see if you all remember how to find what you had to find. So you had to find angle A, E, and R in no particular order. I would suggest you find E first and then R because R is equal to E and then go from yeah. That's correct. Yes, this is a straight line. So the sum of the angles on a straight line is equal to 180. And we have, it's cut into 4 pieces, out of which we have 3. So 90 and 48 is 138, and 138 from that is 42. Yeah. That's correct too. Very good. So the angle at center is double the angle there, right? And half of that is what? That's 78. Yeah. So there's 78 degrees here. There's 78. So yes, you can do that. Yeah, that's actually a more efficient way to do it. Yeah. Right. That's a good spot, Shamo. Good job with that one. Is that one? Right, good spot. Good job. Right. So as you can see, there's more than one way to solve the question sometimes, right? So it's a good idea to look around and see what else you see. Because you see, they put so many lines, I didn't even see that arrowhead in the middle there. And normally I would see it, but just today, I didn't see it today. So don't feel how if you see it. What's that? Oh, okay. One 126 or 156? 126 or just 20 myself? But E. Yes, that's correct. All right, I'm gonna start writing in some stuff here because I'm watching the time. It closing on the last half an hour here. All right, so we are writing all this stuff, boy. Let me see if I can I'm just gonna fit it here. I'm just gonna kind of do a little ratcheting here, right? Not the best thing to do if I want to be the solutions to be usable. All right, so angle E would be equal to 90 minus 12, equal to 78 degrees. And you could say angle between tangent and radius, right? right? And then angle R is equal to angle E, which is the same 78 degrees. Because, so we have two reasons here, right? So you can put angle between tangent and rad and chord. Sorry, I should put like 3 dots here, right? Tangent and chord. Or, right. All right, Hanifa. Right. R is equal to 156 divided by 2. That's because angle at center is 2 times or double angle at circumference. Oh. All right. So hope we okay with those two so far. This is the same question. All right. I was blocking out some stuff there. Right. Yeah. Oh, and to find A. Okay. Right. So we also put in yeah. So this angle here is 42, right? Okay. So to find A, what color for A, boy? I have A and nah, I wouldn't use the same black. I would use, let me use orange. All right. No, I don't actually have a color associated with it. All right. This is a kind of a plum. Right. So angle A is equal to 180 minus 42 plus the 12. Now, we never explained the 12, so we had to go back and explain that. But again, I'm just trying to keep time here, right? 42 and 12 is 54, and 54 from that is 126 degrees, right? So one reason here is that opposite angles of a cyclic chord. You know, I should have put this on the next page. Supplementary. Right? And then this angle here is 90 minus 48, and has angle between tangent and radius. Equal to 90 degrees. Right. So yeah, so you see we're giving you reasons as well. So that way we know we get any marks. All right. I think you all said you were okay with this, right? Javi, you talked to me. We good? I'll see you. All right, cool. Jaden and Noah, we okay here? Noah, we good? Yeah? All right. Nyla, are you working on other things? Yeah? No problem. All right. Josiri, Josiah, Shamo, we okay with all the stuff on the screen? All right. Google Meet, just give me a quick Genie chat, please, and thanks. I want to know how we doing there. All right. Okay. All right. Yeah. All right, cool. So let's go on to. Oh, let me just see Kayla out. Let me print this for my in class people. All right. So tomorrow, you message anybody or? Well, if not tonight, message them during the course of the tomorrow. Yeah. Yeah, the exam pass. I'll give me one. Put 9 to print. All right, so yeah, because you wouldn't have anybody Thursday or Friday. Okay, cool. All right, sounds good. Yeah, yeah. Ooh, better keep a track of that because I don't know how much they bill at one time. All right, cool. So when you put one to print, all right, let's see if that works this time. Yeah, this was the only one I've seen recently where they gave you two different diagrams. But in the first one, they asked you for reasons, and the second one, they asked you for workings. So they just basically wanted to explain why that angle is 45. All right, so start there. Ooh. I'll find a different way to do this for you. Oh Lord. Yeah, so those playing the home game, you're just looking for to be able to explain why Z is 45 degrees. Next one to print one time. Yeah. All right, let's take a read. So WX and right, WX and U are points on the circumference of a circle. Okay. TV is a tangent to the circle at U. So TV is this line here, right? UW is a diameter, right? And they're telling you here triangle WXU is isosceles. And we could see that because these two little strokes here, right? Now, there's a diameter, right? Okay, this point in the middle here, that is usually the what? The center of the circle, right? Which means this line here is a radius. That's a radius. This is a tangent. The angle between tangent and radius is 90. So 90 minus z is how, 90, to find z, we need to find this angle inside here, right? But because the triangle is isosceles, we know that this angle across here and this angle here are equal. And again, we know this is 90 a diameter, right? And we've built a triangle on that diameter such that all three vertices touch the circumference, which means the angle at x is equal to 90 degrees, right? Or again, if you want to say it again, there's a diameter. A diameter cuts a circle in half. Half a circle is also called a semicircle. And the angle in a semicircle is 90 degrees. So if you have 90 degrees here, and some of the interior angles of a triangle is 180, we could find these two by doing 180 minus 90 divided by 2. which will give us that this is 45 and this is 45. Right? And if the whole thing is 90, to find z, we do 90 minus 45. So the three reasons they probably wanted is that the angle in a semicircle is 90 degrees. The sum of the angles in a triangle is 180. And the angle between tangent and radius is 90 degrees. Right? So WXU is 90 degrees. Right? The angle in a semicircle. And then WUX is equal to 180 minus 90, then divide by 2. Now, here, to me, here you have two reasons. Right? Angles in a triangle sum to 180 degrees. And base angles of an isosceles are equal. Or you could simply say two angles in an isosceles triangle are equal. Yo. That's a good question. I would say, yeah, you see, to me, if you couple it with your working, I would say don't be too brief. Don't like give them two words in the whole thing. Don't just say angles in a semicircle, right? You should probably write the whole thing. Yeah, you could do it that way too. There's no one right way to present your working. Yeah, you all right? A bug. Oh. Yeah, related it to add one column, I mean. But I'll flick it off. Right. And then to find z, that's equal to 90 degrees minus the same WUX, which is 45 degrees. Right? 90 degrees, angle between tangent and radius. Yeah, like this one, all right, so like Shamo, this one I write in here. So like I have the 90 degrees and I'm putting an arrow, angle between tangent and radius. So I kind of using the working to kind of fill out the rule now. I would say yes. All right, Google Meet, just give me a quick Genie chat if you're good with what's current on the screen. If you need me to go over or re-explain, give me an R. R for re-explain. R for relp me. Relp. Like Scooby-Doo. 1, 2, 3, 4 out of 5. All right, cool, no problem. Okay, all right, brilliant. Okay, Khalifa and Ziam, we okay with the reasons there? All right. Javier, Noah, and Jadon, are we okay there? Right, Shamo, Josiah, and Jaziri. Cool? All right. I feel like I heard the gate. But that might be Honey for leaving. I don't know. Let's take a peep and. He's still there? Oh, okay. Yeah. If you want, you could ask if she want to wait inside, she's more comfortable now. They have room, they have AC. Right, okay. Ah. Only one print. Yo. If what? After a while, no. Huh? Sorry? Okay, cool, no problem, that's fine. No, like if I talk to one of my friends on FaceTime or something, they be like, wow, those things really loud. I'm like, what things? You don't hear them? After a while, it's just kind of zoned in the background. Like the cicadas and the crickets outside now. It's like how garbage men, after a while, they don't smell the garbage anymore. They just get those lights. It's the same question if you jump. Like I said, it's the only question I've seen in a while. So I give you two different diagrams in a circle question. But the only one two angles here, and they're actually pretty easy to find. So angle X is obvious, angle Y not so much, but you can find it. So too much ado. Right, the diagram below shows a circle with diameter. So please mark, please put that in your brain. It's a diameter. Right, where was I? Right, diagram below shows circle with diameter KF. Right, KF is a diameter. Okay, the line EFG is a tangent to the circle. Right, at F. Okay, the points F, H, K, and J lie on the circumference of the circle. F, H, K, and J. We can see those, right? By showing each step in your work where appropriate, find the value for each of the following angles. Well, there are only two, X and Y. Yo. That's correct. What's the reason? Angles in the same segment, standing on the same arc, are equal. That's correct. Angle Y, that's an interesting one to find there. Oh, okay, cool. Yeah, I'll give you a hint. You had to use the same rule we just used to find X. You have to use that rule again. Tell me. Yeah. Tell me by what letter of the 90? All right, I could agree with that. So H have a 90 here. Right, go through. Okay, so 90 and 56 is 144. 144 from 180 is good. Be yourself. Right, it's 34 degrees. 90 minus 19 will give us 71. So you're saying, okay, so you're saying you found for the angles in that triangle. Good, I could agree with that. And we have a second way to find, which I'll reveal shortly. But I'll give you a hint. The same rule we used to find angle X, we could use again to help us find another angle. And we could do something similar to what Shamor did, which would by finding the angles in a different triangle. And I'll give you one more hint. Yeah, the angle in a straight line is 180 degrees. So if you find the purple angle, you could subtract from 180 and find that angle there. This is a straight line, right? The angle on a straight line is 180 degrees, right? What was the rule we used in part 1 to find X? 56, right? Right, what's the rule? The angles in the same segment, standing on the same arc. Right, good. Can we apply that to any other angles here? Correct? Which means we could find two of the triangles in that triangle, and we could therefore find the purple. Oh, okay. So what Shamor did was he said, okay, this whole angle here is 90, right? Now if you consider the whole triangle, and we have 56 here, right? So 56 plus the 90 is 146 from 180, and then get 34. Right, cool. Hey guys, I keep realizing doing the question and not giving you a chance to do it. So I'm real sorry about that. But as you can see, it have lots more to do. Yeah. But what I will do is I'll take a poll in the chat to see if everybody's back out next week. I know some people still have. Anybody here still have exams next week? What day? Monday. Okay. Anything else? Okay. All right. Remind me. Somebody send my message in the chat to give me the paper one playlist now. I'll just send you a link and you can always go and check out the paper ones. And if you don't have the actual paper one for maths, just send my next request. So, give you the link for the paper ones for maths. I'll send you a Dropbox link. You can download all May and January. Go from there. You could use it, yeah, to find this angle here. Because it's the same rule we used to find 56, to find x. Angles in the same segment standing on the same arc are equal. (19) and 56 will give us 75, which is this is 105. And 105 from 180 is 75, right? And 34 plus 71 is also 105. And 105 from 180 will give us 75. Okay. All right, so so angle x is equal to 56 degrees. Angles in the same segment, standing on the same arc. Are supplementary. Right, so that's I have to find y. So y had a bit more work into it, right? So you could do it different ways. You could use a 90-degree angle in this triangle, or you could use a 19-degree angle in this triangle. Right, so with the 19, you could use the 19 plus the 56 to get 75. And then 75 from 180 is 105. And then you could use the angle on a straight line is 180 to get 75 on that side. So that's some layers. Alternatively, so again, you could use the 90 and the 56 to get the 34. And then 19 from 90 will give us the 71. And then 71 and 34 is 105. From 180 is 75. Okay, I think I'll write that out and then we'll stop there, right? So when we come on Monday, we'll do some more. So we're trying to make sure we get through all the 2020 questions and as many of the 2010s as we could manage. I might have to add some more questions, but I don't know. The pace we go in might be just enough to finish what I have here, but we'll see. Okay, so angle Y. Right, so first of all, so let me say 180 minus 105. All right. I'm working backwards here. So 180 minus the 105 is equal to 75, right? This is because the angle on a straight line. All right, I'll put a little 1 here, and then come down here. So 1, right? So the 105 is equal to 180 minus, what was the 56 and the 19? And here you could say angles in a triangle sum to 180. That was good. Okay, cool. Right, and then we could put a little 2 here by the 19. Right? But that was angle JFK is 19. So JFK is equal to 19. And that was because angles in the same segment standing on the same arc. Right. So yeah, so that was just 3 layers. I thought there was more. 180 minus 105. 180 minus 50 plus 19. And then 19 is that. Okay, cool. Yeah. I'm not gonna reiterate the next version of it. But if you like that one, that's fine. Alright. Alright, so I'm gonna send the PDF of what we did today in class. Now folks, what I could suggest strongly is you all could use the fresh PDF and try the questions over to see if you remember and could do it on your own. Right? Now, again, I'm not telling you when to do that, but the sooner you do that, the better. I know some are in exams, so again, I'm not applying any pressure. I give you no fixed deadline, but just know at some point in time you had to revise. Anyhow, folks, that's about it for today. Right? Today is Wednesday. Already. Wait, but the week almost done. Right? So next time I see you most all is next week, Monday. So if you have any questions and you get to ask during class, please feel free to WhatsApp me. Right? If you need any help or any replays or PDFs, let me know. And yeah, have a good weekend, and I'll see you on Monday. Bye. Yeah, Google Meet, I'll go on there. Right, I actually Donovan today. I actually Jaquan on Logan. Alright, so I know for some people exams in effect, so I'm not gonna worry too much. Okay, alright. Instagram, well nobody there, but I'll go on. TikTok, I see 20 likes coming through. Thanks very much, guys. But that's about it for this evening. Right, I'll see you guys tomorrow for our maths. If you do that maths, 6:30 to 8:30. I think I have a 4 o'clock accounting class, I'm not sure. I might have to cancel that one, yes, but we'll see what we're going to do. Alright, I'll go on.